Today we'll be starting section 9.3. 9.3 is just another set or type of sequences, and they're going to be called geometric. Okay, 9.2 is arithmetic, and then 9.1 was just general sequences of all types. Okay, so what makes something geometric? Well, I'm sorry, let me back up here. We'll get through these two first learning targets. I can recognize, write, and find the nth term of geometric sequences, and then we should get to some of these sums of finite geometric sequences. All right, we know it's geometric if there is some number being multiplied, called a common ratio from one term to the next. Okay, so a way to check it is they're showing you that path. To find R, what you do is you take a term and divide it by its previous to see if something's being multiplied. Okay, so for a problem like 1, most of us can just look at that because we're we can just see that there's some type of multiplier and we're multiplying by 3. But sometimes there might be a decimal multiplier and it might not be that obvious just to look at. So it's good to make sure we have or we understand this process too. So for example, to find if R exists, it says I take the second term and divide it by the first term. So I take 6 and divide it by 2. And just check to see that they're all equal. Take 18 divided by 6. Does this work out? Does 54 divided by 18 equal the same thing? Yeah, all of these are equal to 3. Okay? 162 over 54. It's not something you really got to show a lot in your work. I'm just demonstrating how we find the common ratio. Okay? So the question is, determine whether it's geometric. We did because if the common ratio exists, we call it geometric. So, and if so, find the common ratio. Okay, so R equals 3, and yes, geometric. Okay, these go pretty quick. Why don't you try 2 and 3. See if you can determine if they are geometric or not, and then find the common ratio. Pause and give it a try. All right, here's 2. What's being multiplied? Now, this is a fraction multiplier now. So if you can't quite see it, just stick to what you're supposed to do. Take a term, divide it by its previous. Take a term, divide it by its previous. It usually only takes you 2 times to see if it's common, but I might want to check all the way through. So the common ratio is negative 1/3 when we simplify those. Okay, or negative 0.3 repeating. So yes, geometric. All right, number 3, we take a term and divide it by its previous. 1/4 by 1/3 gives us 0.75 or 3/4. And then if I take 1/5 and divide it by 1/4, it gives me 0.8 or 4/5. These are not common, right? So we would not say that is geometric. So I put the ratio is not common. I can stop there. I don't need to keep checking. It's not geometric. Okay. All right, 4 is a little more of a challenge one, but I'll just go through it with you real quick. You just got to separate the top and bottom and take a look at it. What's being multiplied on the bottom? Just e to the first power, right? That's what's being multiplied to go from e squared to e third. So the common ratio on the bottom is the multiplier is e, and then up top, 3, 9, 27 being multiplied by 3, right? So it's 3 over e. Okay. You could also divide it, but that might get a little bit tougher with the algebra. You can also just ask yourself, what is being multiplied to get the next term? Okay. Okay, this next set is really just checking to see if you understand the definition of a geometric sequence. It has a multiplier. That's it. That's all you have to know really to start number 5. Write out the first 5 terms of the geometric sequence. So if the first term is negative 3, how do I go from that term to the next one? I have the multiplier given. The common ratio is negative 4. Just like here on number 1, if I told you the common ratio is 3, well, how do we get the next term? You multiply by 3, and so on. So here we're multiplying by negative 4. Okay, so negative 3 times negative 4 is positive 12. And you keep going. No work you need to show. If this is a free response problem on your quiz, you don't need to type all that. The work in, just start multiplying and give the sequence. Okay, so then we multiply again, we get negative 48. We multiply again, we get 192. And then negative 768. Okay, alternating signs because of the negative. All right, try for 6. All right, so we're taking 1/2 of each term. This one's going down. So here we have 3/2 or 1.5. Might just want to keep it in this form because then it's easier to multiply by 1/2 one more time. Because you multiply by fractions, top times top. So 1 times a 3 and 2 times a 2. So now we're at 3/4. 1, 2, 3, 4, 5. I've got my 5 terms, and I'm done. All right. Let me get the first term going for you for 7, then see if you can continue. First term's 5, given. How do I get the next term? Well, that's the multiplier, just an algebra expression. So we take 5, I just put it over 1, multiply that by x over 4. Well, that gives me 5x over 4. Okay, so this is just going to be an algebra expression because they gave us a ratio of an algebra expression. All right, now multiply 5x over 4 times x over 4 again. Okay, keep going. See if you can get the next 3 terms. Pause and try it. Okay, so there's the final result. If you keep multiplying them, the top by x, bottom by 4, we get this sequence. 5x squared times x, 5x cubed, multiplied by 4. Okay. All right, let's go ahead and take a look at the next example. Okay, so this is another formula that you'll be given on your next assessment. This is for geometric. Remember, arithmetic was a little different. It was a1 plus n minus 1 times d because they had a common difference. It has a common ratio. It's going to be geometric. Okay. All right, so write an expression for the nth term of the geometric sequence, and then find that missing term. Okay, so a sub n equals, just follow this format, right? I'll just rewrite it right here just so you have it right in front of you. Okay, the form up there, I didn't put r in parentheses. I think it's a good idea to do that. All right, so plug in what we know. First term is given as 3. Common ratio is -2, and we're going to raise that to the n minus 1. Remember, if we're writing a formula for the nth term, keep it in terms of n. Now we can use it for the 100th term, 50th term, or whatever they're asking for, in this case, the 6th term. So there's 2 answers to this problem. A sub n formula, and then use it to find the 6th term. Okay, so that's going to be just to the 5th power now. So 3 times -2 to the 5th. We can punch that all in at once. So the calculator knows to do the power first, but if you were doing this one step at a time, do the -2 to the 5th, then multiply by 3, or just put that in parentheses and do it like that. So we get -96. Okay, should be enough for you to try 1011. Pause and do 1011. Should only take you about a minute a problem, maybe 2. Go ahead. Okay, should be back on 10. Okay, I'm asking for 2 things. Formula, 7th term in that case. This one, formula. Now, if you wanted to not write 1 there, fine, because 1 times anything is just that. So we could drop that 1. 6th term now, when you plug it in there, do square root of 3 to the 5th power, and we get 15.59, somewhere around there. Okay, so for 13, they just don't give us the common ratio, but we've already gone through how we find common ratio. So once you find the common ratio, it's going to be a lot like 9, 10, 11. So it's really putting the last couple of questions together for you. So the first step, if you don't realize that, you might want to write it down in words. We need to find the common ratio if it's not given. Or what's the multiplier, right? So I take 125, divide it by 625. It's 1/5. Now, a lot of times we need to keep going to verify that it is geometric, but they're putting this in the geometric set. But you can just double check, right? The calculator, 25 divided by 125. Do they all equal 1/5? Yes, we can confirm that. And now we're ready, right? A sub n equals A1, which is 625, R raised to the n minus 1. Your turn, try 14. Okay, this multiplier is -5. So once you figure that out, there's our formula. And that's it. That's all they're asking for. Okay. All right, I want to show you one more example today. The sum of a finite geometric sequence on this next page. Let's Go there now. All right, so here's the sum formula over here. S of n equals, you can kind of ignore this part. It just says from 1 to n. But it says to take the first term and then multiply it by this. So we need the common ratio and obviously the number of terms. You always need the number of terms. So those are the three things we have to kind of gather. Once we gather those things, we set it up, and I'll just show you how to punch in the calculator and we'll get our answer. Okay? All right, so find the sum of the finite geometric sequence. First thing we need to find is r. Now, a lot of times these are set up in that formula, a sub 1 r raised to the n minus 1. So you might catch on and realize that that's 3, but if not, we have to find the first term anyway. So here's what I recommend. Why don't you write this down? Let's get this sequence going. So a1 is going to be 3 raised to the 1 minus 1. Okay, I'm just using my formula right here. All right, so that's 3 to the 0, which is 1. I'm going to go ahead and find the second term as well so we can figure out the common ratio. The second term would be 3 raised to the 2 minus 1. So 3 to the first, which is 3. I even did one more just to verify, but since they already told us it's geometric, I guess that would be enough. You can figure out what that multiplier is. All right, but if you're not sure and wanted to do one more, that's what I did. A sub 3 is going to be 3 squared, or 9. Pretty clear this is geometric. Pretty clear what the common ratio is, right? Okay, remember how you read the summation notation. It says find the sum from term 1 to 7. So that's my n value. It's going to be 7 terms. I have everything I need now to set that formula up. So here we go. S of 7 equals A1, which was 1. Okay, and then the formula up there says 1 minus r to the n power all over 1 minus r. Okay. All right, here's what I recommend doing. If you punch in too much at once, a lot of times students will make mistakes. So what I recommend doing is just cleaning up the numerator, cleaning up the denominator separately. So what I mean by that, just go in and do the 1 minus 3 raised to the 7th. Just punch that in. And what do we get? Gives me negative 2186. Obviously, 1 minus 3 is negative 2. I'm not going to punch that in. So that's my next step. Negative 2186 divided by negative 2 is 1093. Okay. All right, we'll take you through 16. 16 is slightly different just because it starts at 0 instead of 1. So it says start at 0, then go to 5. Which is technically 6 terms if you think about it. 1 to 5 is 5 terms. So if it's term 0, they've added an extra term, so n is 6. Okay, so from 0 to 5, we need to realize n equals 6. All right, so let's go find the common ratio again and the first term. So the first term is a of 0. So 4 negative 1/2 to the 0 power. And what do we get? Well, negative 1/2 to the 0 is 1. 1 times 4 is 4. Okay. Just get one more term so we can get the common ratio and then get the sum. So if I plug in 1 now to get the next term, I get half of 4, which is negative 2. So now you should be able to tell what the common ratio is. Okay, it's being multiplied by negative 1/2. I confirmed it one more time, but you don't really need to. Okay, so see if you can set up the formula, and then I'll give you feedback on punching the calculator. Go ahead and get ahead of me here. Okay, so just be careful here. When you subtract the negative, it's positive, but actually we got to raise it to the 6th power first, so don't simplify that. Just punch it in just like this. 1 minus 0.5 to the 6th, and enter. I get that. I divide it by now 1.5 to get this, and then I got to multiply it by 4. So that's a good way to do it. We'll practice that a little more. But that's how I got my final answer. Okay.